Hey Java developers, JDK 23 has been released. A new release of the JDK means new features being added, some being removed, and a few being deprecated, along with the bug fixes that come in every release. In this episode of the Inside Java Newscast, we'll go through everything that's included in the release notes for JDK 23. Once again, I have slightly changed up the format of the content. I have added a new section, Tooling. The goal I have with this is to try to divide up the content based upon what different personas and or areas of interest people might have when watching this video. To that end, I imagine there will be roughly 4 developers wanting to be aware of what changes are coming in the JDK that affect their day-to-day, operation folks who are looking to maximize performance or improve monitoring, and of course security to ensure applications are meeting compliance and secure against bad actors. Because release notes can be a bit of dry reading, it might be easy to accidentally overlook a change that might be important to your organization. That said, how some of this is divided up is based upon my interpretation. If you think a change was in the wrong area or have a suggestion on how either this video or our release notes could be improved, please leave a comment. We'd be happy to hear from you. In the bottom left-hand corner of the screen will be the ID for the current JEP, JDK Enhancement Proposal, or JBS, Java Bug System, issue I am covering. I will provide links to both the root, JEP page, and JBS Jira dashboard to make lookup a bit easier if that change is of particular interest for you. Be sure to check the chapters if there is a particular section you'd like to jump to, and the description as well for helpful links. With that said, let's get started. JavaDoc now supports Markdown, specifically the upmark notation. This should help improve the readability of JavaDoc when viewed from a source code file, as HTML can be a bit verbose. Markdown JavaDoc comments are denoted by starting a line with a triple backslash. For more on this change, check out this video by Anna Maria. The generational mode for the Z garbage collector or ZDC will now be the default when using ZDC. To use the single generation mode, you will need to pass the JVM argument minus Z generational, though the single generational mode will be deprecated and eventually removed in future releases, so make sure you have your migrations to get off single generational ZDC in order. Just to clear up any possible confusion, the G1 garbage collector remains the default garbage collector on the hotspot JVM, unless otherwise explicitly declared. The memory access methods in SUN-MISC-SAFE have been deprecated for removal in a future release. These unsupported methods have been superseded by standard APIs, namely the var handle API added in JDK 9 and the foreign function and memory API added in JDK 22. We strongly encourage library developers to migrate from SUN-MISC-UNSAFE to supported replacements so that applications can smoothly migrate to modern JDK releases. There are 8 preview JEPs included in JDK 23. JEP 455 introduces primitive types in patterns as a first preview. As the name suggests, the goal of this JEP is to allow developers to reference primitives, boolean, byte, char, double, float, int, long, short, and patterns. Fundamentally, the goal of this JEP is to reduce friction when using patterns and primitive values. The class file API has been re-previewed in JDK 23 with JEP 466. There are a number of changes to the class file API in this new preview round. Not familiar with the class file API? That's okay, as it's not going to be an API most developers will work with, but if you're a library developer, you're probably going to look forward to this change. Check out this IJN episode from Nikolai Parlog on the class file API for more, and see the JEP for details on what has changed with Preview 2. Stream Gatherers also enters second preview in JDK 23 with JEP 473. There are no changes proposed for the Stream Gatherer API, and indeed, as I was writing the script for this episode, JEP 485 was published, which promotes Stream Gatherers to a final feature which is scheduled to be part of the JDK 24 release. Module import declarations were introduced as a preview feature in JDK 23. Module imports allow the importing of all the public API of a module with a single line. So, for example, adding import module java.base has the same effect as importing all the classes located in the Java base module. This feature can be useful for new developers who aren't familiar with the package structure of the JDK, or when writing new code where having to declare each specific import could be a distraction. When there is an ambiguous class name, for example, if you were to import java.base and java.sql, which both contain a date class, that ambiguity can be resolved by explicitly importing the specific version of the date class you intend to use. Implicitly declared classes and instant main methods enters third preview with JEP 4.7.7. The goal of this feature is twofold. For developers learning Java, it's about making the process of learning Java easier by providing a smooth path for learning new features, or paving the on-ramp, if you will. For more experienced developers, these features will make Java a more practical option for writing small utility programs or scripts. Something I am very much looking forward to, as I've largely forgotten all my bash scripting from my college days. In this round of preview, there were two changes. One, implicitly declared classes will automatically import 3 public static methods located in the new Java IO class. 2, implicitly declared classes will automatically import all the public top-level classes declared in the java.base module. Structured concurrency enters a third round of preview with JEP 4.8.0. There were no changes proposed in this round of preview for structured concurrency. However, significant changes are coming to the structured concurrency API. We'll cover all those new changes when the Loom team publishes the JEP, so be sure to subscribe to this channel so you won't miss that video when it's published. Scope values are also re-previewed in JDK 23 with JEP 4.8.1. There was only one change in this preview. The type of the operational parameter of the scoped value call where method is now a new functional interface, which allows the Java compiler to infer whether a checked exception might be thrown. With this change, the scope value getWhere method is no longer needed and removed. Flexible constructor bodies, previously named statements before super in JDK 22, entered second preview in JDK 23 with JEP 4.8.2. As the name suggests, the purpose of this JEP is to loosen the restrictions when writing a constructor. This is primarily related to subclasses. Historically, or I guess currently as far as final features are concerned, the constructor of a subclass must always begin with a call to the constructor of the superclass, either implicitly or explicitly. While this can create predictability in the body of a constructor, it comes at the cost of forcing developers to write substandard code in order to ensure the instance of the constructor it is creating is valid, like shown in this example of positive big integer. The change in this revision of the JEP is that constructor bodies can now initialize fields within the same class before the explicit call invoking a superconstructor. The only JEP that remains in incubator status is the Vector API, JEP 4.6.9, which will remain in incubator status pending release of Valhalla features. For an update on Project Valhalla, watch this video from JVMLS. As mentioned, there were only 12 JEPs included in this release, not 13. And that's because string templates previewed in JDK 21 and 22 has been withdrawn, ultimately based upon internal testing and public feedback. It was determined it was better to withdraw string templates for now, while a better solution can be worked on for a future release. But the intent is to come back with a new solution. It's not goodbye forever, but see you later. I understand this news might disappoint some Java developers. Certainly, I was looking forward to using string templates. However, as I like to say, once you make an API public, you have to support it forever. Forever. If you want to learn more about this, be sure to watch this episode of the Inside Java Newscast. There is one important behavior change that's worth calling out. Annotation processing in Java-C has been disabled by default. Annotation processing was originally added nearly 20 years ago with JSR 269 in JDK 5. At the time, it was implemented as a default option and it could be disabled with the flag proc none. Now, 20 years later, annotation processing isn't used as heavily and can represent a security vulnerability. If you follow the link for this JBS issue, it goes through a scenario where a library version is updated with malicious annotation code, which is used to infect a CI server. Anyways, this is following an update where in JDK 21 and 22, which issued warnings when annotation processing was occurring, indicating that you would need to add the new flag proc full to explicitly enable annotation processing. This flag has been backported to JDK 17, 11, and 8, though 8 would be OracleJDK only. Tool vendors are also already supporting this flag with Maven. This annotation processing can be configured with the property Maven compiler proc. Several new features have been added to the JDK with this release that don't quite reach to the level of going through the JEP process. 4 new methods have been added to the class Java IO console. They are format, printf, readline, and password, all which take a Java util locale as an argument, which can be used to override the default locale. This way, if your default locale was US English, but you wanted to format a date in Mexican Spanish, you can accomplish it like in this example. The new JFR event, JDK serialization misdeclaration, has been added. This event is triggered at runtime when either a field or method related to serialization is declared incorrectly. For example, declaring write object as public, which can cause it to be not called by the serialization machinery. Luckily, this is the only known issue related to serialization in Java, and it is otherwise a totally great feature with no other known drawbacks. Note, this event is not enabled with default configuration, but is enabled with profile configuration. In previous JDK versions, implementations of the Java NIO file watcher service had a buffer for maximum number of events before discarding events and then queuing the overflow event. A new system property, jdk.nio.file.watch service max events per poll, has been added to allow a user to define a maximum number of pending events which may be in queue before an overflow event is emitted. The value of this property must be a positive integer. A new method has been added to the Java time instant class, instant until instant, which returns an instance of duration which contains the time until the specified instant. This method behaves similar to the duration between temporal, and is easier to use than instant until temporal units. A new sub-option has been added to the Java C excellent to detect issues related to the placement of documentation comments in source code. It can be enabled explicitly with the excellent dangling comments or implicitly with excellent or excellent all. The purpose of this option, as the name implies, is to find misplaced documentation comments like in these examples. Note that warnings can still be suppressed locally with the annotation suppress warnings. XML processing will continue towards getting more restrictive by default in future JDK releases. To help prepare developers for this, this release includes a JAXP configuration filter template located under conf JAXP properties template in your Java install directory, which specifies XML processing settings. The following steps may be used to test an application with the JAXP configuration file template. Of course, good stewardship isn't just about growing the JDK, but also knowing when to remove features. In this release, the following features were removed. The methods Java lang thread suspend end and resume and Java lang thread group suspend, resume, and stop have been removed in this release. These methods were deadlock prone and have been deprecated in JDK 1.2, which was released in 1998, a time period that I hear Gen Alpha likes to refer to as the late 1900s. These methods were deprecated for removal in Java 14 and have been throwing unsupported operation exceptions since Java 19 and 20. The var handle returned by method handles byte of array view var handle no longer supports atomic access modes, and the var handle returned by method handle's byte buffer view var handle no longer supports atomic access modes when accessing heap buffers. Additionally, byte buffer aligned slice and byte buffer alignment offset methods are updated to reflect these changes. They no longer report aligned slices or offsets for heap byte buffers when the accessed unit size is greater than 1. They instead throw unsupported operation exception in those cases. For more on this change, be sure to check out the JBS issue. The JDK.random module has been removed from the JDK. The contents of this module containing the implementations of Java util random.random generator have been moved to Java base. Applications that relied on JDK.random module either through their build scripts or through module dependencies should remove references to this module. The legacy JRE locale data compat has been removed from the JDK. CLDR data has been the default locale data since JDK 9. Compat locale data has been deprecated for removal since JDK 21. Setting JRE or compat for locale.java.locale providers no longer has any effect. If you're still unable to move to CLDR locale data, there are several workaround options covered in JEP 252. Link to that section of the JEP in the description. Also, a part of good stewardship is giving users time to migrate off features that will be removed in a future release. The following features are entering deprecation with JDK 23. The package Java Beans Bean Context added in JDK 1.2 was well in advance of now common language features and paradigms, including annotation, lambdas, modules, declarative configuration, dependency injection, and inversion of control. As a result, many of these APIs are now both obsolete and express an anti-pattern of component assembly and interaction. They are therefore deprecated for removal in a future release. Developers should no longer use these APIs. They should plan to migrate any existing code dependent on this package to an alternate solution in anticipation of their future removal. Several issues have been resolved in JDK 23, aka bug fixes. The HTTP server no longer immediately sends response headers if chunked mode is selected or if the response has a body. The previous behavior had the effect of slowing down response times due to delayed acknowledgements on some operating systems. With this change, the headers will be buffered and sent with a response body if one is expected. This should result in improved performance for certain kinds of responses. Note, it is advisable now to always close the HTTP exchange or response body stream to force the sending of the response headers, and is required in all cases except where there is no response body. Message format objects are created from the pattern strings that contain nested sub-format patterns. Conversely, the message format to pattern method returns a pattern string that should be equivalent, though not necessarily identical, to the original. However, if a nested sub-format pattern contains a quoted that is intended to be plain text, opening or closing curly brace character, like in this example, in some cases that quoting could be incorrectly omitted in the pattern string. As a result, this bug, creating a new message format from this pattern, could fail to parse correctly, throwing an exception or parsing differently, resulting in a new instance that was not equivalent to the original. This problem has now been fixed. The fix does not change the behavior of message format objects whose message format to pattern output was already correctly quoted. For a java.text decimal format created with an empty string pattern, the value returned by decimal format get maximum fraction digits will now be 340 instead of integer.max value. This prevents an out-of-memory error from occurring when decimal format to pattern is called. If 340 is too low, it is recommended to achieve this behavior using the method decimal format set maximum fraction digits. Local classes declared inside superclass class constructors and invocation parameter expressions are no longer compiled with the immediate closing outer instances. This is to match the behavior defined in JLS 21.15.9.2. This code example demonstrates the behavior that will no longer be supported. For more on this, see the description of the JBS issue. A bug has been fixed in JavaDoc. Previously, the C and link tags allowed a nested class to be used to qualify the name of a member of the enclosing class. They no longer do so. Because of this, documentation comments that were previously relied on this behavior will now trigger a warning or error when processed by JavaDoc. In previous releases, random generator factory create long falls back by invoking the noargcreate method if the underlying algorithm does not support a long seed. The create byte method works in a similar fashion. Starting with this release, these methods now throw an unsupported operation exception rather than silently falling back to create. The gzip input stream read methods have been modified to remove the usage of input stream available when determining if the stream contains a concatenated gzip stream. These methods will now read any additional data in the underlying input stream and check for the presence of a gzip stream header. The locale data based on Unicode Consortium's CLDR has been upgraded to the version 45. Besides the usual addition of the new locale data and translation changes, one notable number format change affecting the Java text compact number format class is the compact form of the Italian million switched back to MLN. Remember that CLDR locale data is subject to change with future releases, which may or may not affect the JDK. For more details on CLDR updates, check the Unicode Consortium CLDR release notes, link in the description. With JDK 23, the method JavaX model type mirror to string for an inner class always returns a qualified class name. As mentioned, this is a new section I added for this video. In this section, I try to cover any changes that cover the operational aspects of the JDK, so things like changes to monitoring the JVM, installation process, and updates to JDK tools, I'll put here, unless it's otherwise more appropriate in another location, like for example the update to Java-C regarding inner classes in the bug fixes section, which is something that would be primarily of interest to developers. API documentation generated by the standard docklet now comes with enhanced navigation features, including a sidebar containing a table of contents for the current page and breadcrumb navigation for the current API element in the page header. In the documentation for classes and interfaces, entries in the table of contents can be filtered using a text input field at the top of the sidebar. A button at the bottom of the sidebar allows the table of contents to be collapsed or expanded for the current section. Just as a reminder, or emphasis, all these JavaDoc features are available to you as a developer for your own projects. The JavaDoc team has made considerable improvements to JavaDoc over recent releases and has truly become a powerful feature for providing documentation for your applications and libraries. Let me know in the comments if you'd be interested in a deep dive on various JavaDoc features. Also on the subject of JavaDoc, the JavaDoc add script option now supports JavaScript modules in addition to conventional script files. Modules are detected automatically by inspecting the extension or content of the file passed as an option argument. And lastly on JavaDoc, by default, the generated API documentation now includes Deja Vu web fonts used by the default style sheet. A new no fonts option was added to the standard docklet to omit web fonts from generated documentation when they are not needed. There were a number of updates regarding monitoring tools and frameworks like JMX, JVM-TI, and others. In preparation for the removal of the security manager, as covered in JEP 4.1.1, the Java Management Extensions, JMX, subject delegation feature has been removed. JavaX Management Remote JMX Connector Get M Server Bean connection will now throw unsupported operation exception if invoked with a non-null delegation subject. if a client application needs to perform operations as or on behalf of multiple identities, it will now need to make multiple calls to JMX connector factory connects and to the get mbean server connection method on the return JMX connector. The class loading mxbean set verbose method will set class plus load logging on log output standard out to level info if enabled and off otherwise. In contrast, the isVerbose method would check if exactly class plus load logging was enabled at the info level on any log output. This could result in the counterintuitive behavior when logging class plus load equal info to a file via the command line, as it caused isVerbose to return 2 even after a call to setVerbose has been made. A similar problem existed for the memory mx isVerbose method. Starting with this release, this behavior is as follows. Class loading mxbean isVerbose will return true only if class plus loading star logging, note the wildcard use, has been enabled at the info level or above on standard log output. Memory mxbean isVerbose will return only if GC logging has been enabled at the info level or above on the standard log output. The Java TI function getObjectMonitor usage has been respecified in this release to not return monitor information when a monitor is owned by a virtual thread. It is now specified to return the monitor owner only when the monitor is owned by a platform thread. Furthermore, the array of threads waiting to own and the array of threads waiting to be notified that the function returns are now respecified to only include platform threads. The corresponding JDW command, object reference, monitor info, is respecified. The methods owning thread, waiting threads, and entry count defined by com_sun JDI object reference are also respecified. The VM option preserve all annotations is deprecated. Using this option will produce a deprecation warning, and this option will be obsoleted and then removed in a future release. The JVMTI getObjectMonitor usage function returns the following data structure. Two fields in this structure are as specified. Waiter underscore count, the number of threads waiting to own this monitor. Waiters, the waiter count waiting threads. In previous releases, the waiter fields included the threads waiting to enter or re-enter the monitor as specified, but also incorrectly the threads waiting to be notified in Java Lang object wait. This has been fixed in the current release. The waiter count always matches the number of threads in the waiters field. Also, the JDWP object reference monitor info command spec was updated to clarify what the waiter threads are. Waiters, the total number of threads that are waiting to enter or re-enter the monitor or waiting to be notified by the monitor. The behavior of this JDWP command is kept the same and is intentionally different to get monitor usage. The JVMTI get current contingent monitor implementation has been aligned with the spec. Thus, a monitor is returned only when the specified thread is waiting to enter or re-enter the monitor, and the monitor is not returned when the specified thread is waiting in the Java Lang object wait to be notified. The JDWP reference current contingent monitor and JDI thread reference current contingent monitor command specs have been updated to match this. The JStack command in JSHDBB CLHDSB has been modified to scan for Java util concurrent logs only if the given L option. Searching for these logs is a very expensive operation that requires scanning the entire heap. The HSDB, JStack, and bin JStack commands also have the ability to include this logging information in the output, but do not do so by default. A new Java P option, verify, prints additional class verification info. For Linux users, here are a few updates you should be aware of. Native executables and libraries on Linux have switched to using rpath instead of runpath in this release. JDK native executables and libraries use embedded runtime search paths to locate other internal JDK native libraries. On Linux, these can be defined as either rpath or runpath. The main difference is that the dynamic linker considers our path before the LD underscore library underscore path environment variable, while one path is only considered after LD underscore library underscore path. With this change, it is no longer possible to replace JDK internal native libraries using LD underscore library underscore path. Non-functional desktop integration functionality for Linux installers has been removed this release. The installers will stop depositing files in user share icons, user share mime, user share application subtrees. The format of the installation directory name in the OracleJDK in RPM and DEB packages has changed from this path to this path. Consequently, every update release will be installed in a separate directory on Linux platform. An issue was fixed in JPackage on Debian Linux distros, where JPackage could not always build an accurate list of required packages from shared libraries with symbolic leaks in their paths, causing installations to fail due to missing shared libraries. There have been a number of updates and improvements to performance in JDK 23. I would also encourage checking out Thomas Salzel's blog article, where he goes into more depth regarding changes to the serial, parallel, and G1 garbage selectors, as well as plans for the future on all. Link in the description. Starting with OracleJDK 23, the Oracle GraalVM JIT compiler, GraalJIT, is now included as among the JITs available as part of the OracleJDK. This integration offers innovations previously made available via GraalVM, such as JIT code optimization techniques, to all OracleJDK users. This provides developers and sysadmins more options to help fine-tune and improve peak performance of their applications. The GraalJIT is enabled by passing these command line options to the Java executable. If you do not pass these flags at JVM startup, the OracleJDK default JIT C2 will run as usual. During the concurrent phase, G1 may increase the stack size on demand, starting from a minimum and potentially reaching a maximum value defined by the mark stack size and mark size stack size max command line options. Previously, G1 has been unable to grow the marking stack during the reference processing phase in the remark phase, which could result in a mark stack overflow error that exits the virtual machine before reaching the limit imposed by mark stack size max. With this update, the marking stack is allowed to expand during reference processing, preventing this premature overflow error. The parallel garbage collector has been updated to use the same full GC algorithm that is used in the serial and G1 garbage collectors. This change should see significant performance improvement with certain workloads, while also reducing footprint for all workloads. For more details on this change, be sure to check out the JBS issue. An existing bug may have prevented the full usage of the Java heap allotted with the command line flag max heap. That bug has been fixed. As a side effect of this fix, installations may experience an increased heap usage when using parallel GC. Customers should, if necessary, adjust the max heap size. For general performance improvements and updates to the hotspot runtime, one hotspot virtual machine internal class to indicate an area of dead, unreachable memory has been renamed to conform to the Java class naming standard to avoid confusion. External applications parsing virtual machine class histograms provided by the JMap histo. There are applications that parse the output of JMap histo, which fail when encountering the class JDK VM internal filler array. In particular, the issue is this type of filler object represents a flexibly sized range of unreachable memory, but is named as if it were a fixed size of non-array object. Then, for example, calculating the instance size of these objects from the JMap histo output can result in non-integral instance sizes, confusing applications. This problem has been fixed by changing the name of this class to the array like JDK internal VM filler element. The invoke virtual bytecode implementation relied on spinning up machine code stub called inline cast stubs to achieve better performance. However, these stubs were created in a buffer of fixed size, and when the buffer got exhausted, save points would be scheduled to refill the buffer. This could lead to latency issues. It was particularly problematic during concurrent class unloading using GDC. The issue has been resolved by going back to the original problem the stubs set out to solve and solving it in a different way without any stubs. Array element bases are no longer unconditionally aligned to 8 bytes. Instead, they are now aligned to their element type size. This improves the footprint in some JVM modes as Java element alignment is not exposed to users. There is no impact on the regular Java code that accesses individual elements. Of course, there are some implications, irregular Java code, such as using the ever popular sunMISC unsafe. Check the JBS issue for additional details. A new locking mode, LM_lightweight, was introduced in JDK 21. This locking mode is now the default. To use the old LM_legacy, pass the command line flag locking mode equals 1. Though note that this mode is expected to be removed in a future release. Trim native interval has been made an official product switch. It allows the JVM to trim the native heap at periodic intervals. This option is only available on Linux with glibc. The following options have been deprecated. The undocumented don't yield a lot product flag was introduced to mitigate a scheduling anomaly that could arise on the Solaris operating system. It has not been needed for many years, nor has it operated as described for many years. The flag has now been marked as deprecated and will be obsoleted and then removed in future releases. The option plus use empty slots in supers has been deprecated in JDK 23 and will be obsolete in JDK 24. The default value is true. This means that the hotspot JVM will always allocate fields in a superclass during field layout where there is aligned space to fit the fields. Code that relies on the position of the instance fields should be aware of this detail of instance field layout. The JVM field layout is not specified in the JVM LS and is subject to change. The VM option use notification thread is deprecated. It will be obsoleted and removed in future releases. When debugging notifications were switched from being sent by the hidden service thread to the non-hidden notification thread, this option was provided defaulting to true so that it could be disabled if any problems arose using the notification thread. As problems have been reported, the notification thread will become the only way that notifications are sent in the future, and the option will no longer be available. The VM option preserve all annotations is deprecated. Using this option will produce a deprecation warning. The option will be obsoleted and then removed in future releases. This option was introduced to support testing of Java annotation code and has always been disabled by default. For removed options, the XNoAgent Java Launcher option, which was deprecated for removal in JDK 22, has been removed. The option has been treated as a no-op for several releases now, even before being deprecated for removal. Launching Java with this option will now result in an error. As always, there are a few security updates to be aware of in JDK 23. I would also follow Inside.java. Sean Molan, the Java security lead, always puts out an article on security updates after a JDK release, which will be posted there when it's published. Also check the description of this video. I'll update it as well when that article is published. The java.security.debug system property now accepts arguments for adding thread ID, thread name, caller information, and timestamp information to debug statements for all components are a specific component. Thread ID, thread name, caller information can be added with the plus thread option, and timestamp with the appropriately named plus timestamp option. Like in this example of Java security debug equals all plus timestamp plus thread. For additional details on these options and others, you can run Java security debug equal help, which prints out a help message. Keychain Store on macOS now supports two types of key stores. Keychain store contains private keys and certificates for the user's current keychain. Keychain store -root contains certificates from the system root certificates keychain. When looking up a key tab or credentials GCAS entry from a Kerberos principal, the principal name is compared with the entry name in a case-insensitive manner. This may not be desirable. To address this, a new property, JDK Security KRB5 name case sensitive, was added. By default, the value is set to false for backwards compatibility, but can be set to true to look up entry names in a case-sensitive manner. In addition, if a system property with the same name is specified, it will override the security property value defined in the java.security file. The size of Cypher input stream's internal buffer has been increased from 512 bytes to 8,192 bytes. The usage of the terminally deprecated method subject get subject access control context will throw unsupported operation exception when security manager is not allowed. This method will continue to be degraded in future releases. It is strongly encouraged to migrate off this code. There are a lot of more details on this issue in the JBS issue, so be sure to check it out and the release notes if this change impacts you. JDK 17 introduced performance improvements that made OCSP clients unconditionally use GET requests for small requests while doing POST requests for everything else. This is explicitly allowed and recommended by RFC 55019 and RFC 6960. However, we have seen OCSP responders that despite RFC requirements are not working well with GET requests. To address this issue, we have introduced a new system property, ComSun Security OCSP use GET, which takes a Boolean value with a default of true. Any other value besides a valid Boolean value will also be defaulted to true. Debug output related to JGSS Kerberos, including those for JAS and KRB5 login module, the JGSS framework, and the Kerberos 5 and Spigno mechanism, is now directed to the standard error output stream, i.e. system error, instead of the standard output stream, system out. Additionally, debug output is now prefixed with a category tag such as KRB5 login module, JGSS, Kerberos 5, and others. Finally, for security changes, there were a number of certificate updates for the global sign and certainly. The following root certificates have been added to the CA Cert Trust store. Although we have stated the goal to have OracleJDK and OpenJDK binaries be as close to each other as possible, there remain several differences between the two options. The current differences are: OracleJDK includes GraalVM JIT as an optional compiler. OpenJDK does not. OracleJDK offers installers which not only place the JDK binaries in your system, but also contain update rules and in some cases handle some common configurations like set comment environmental variables, such as Java Home in Windows, and establishes file associations such as use Java to launch .jar files. OpenJDK is offered only as a compressed archive, tarball, or zip. Usage logging is available only in OracleJDK. OracleJDK requires that third-party cryptographic providers be signed with a Java encryption extension, JCE, code signing certificate. OpenJDK continues to allowing the use of unsigned third-party crypto providers. The output of Java.version is different. OracleJDK returns Java and includes the Oracle-specific identifier. OpenJDK returns OpenJDK and does not include the Oracle-specific identifier. OracleJDK 17 and later are released under the Oracle No-Fee Terms and Conditions license. OpenJDK is released under the GPL v2 WCP license. Files included in each will therefore be different. OracleJDK distributes FreeType under the FreeType license, and OpenJDK does so under GLP v2. The contents of legal Java.desktop FreeType is therefore different. OracleJDK has the cup and steam icons, and OpenJDK has Duke icons. OracleJDK source code includes Oracle proprietary confidential. Use is subject to license terms. Source code distributed with OpenJDK refers to the GPL license terms instead. All right. that's it for the release notes for JDK 23. I hope you find these videos useful. As I mentioned in the intro, reading the release notes isn't exactly exciting reading. A goal of these videos is you can possibly listen to it while you're doing other tasks and make mental notes for important changes to look into later. If you have suggestions for how these videos might be improved, leave a comment. Also, don't forget to check out our JDK 23 launch live stream where we interviewed the JDK engineers that actually implemented the code behind all these JEPs and JBS issues I covered. Until next time, happy coding!